Hey, here is the video presentation on the topic, First-Order Logic, presented by Anjo Sassi. The contents for the presentation are, limitations of propositional logic, first-order logic, inference in first-order logic, substitution, equality, first-order logic inference rules for quantifier, universal generalization, universal instantiation, existential instantiation, existential introduction, generalized modus Ponens rule. Why first order? Inference with GNP, inference in first order logic. And review, first order logic inference. Limitations of propositional logic. In propositional logic, we can only represent the facts, which are either true or false. Propositional logic is not sufficient to represent the complex sentences or natural language statements. The propositional logic has very limited expressive power. Consider the following sentence, which we cannot represent using propositional logic. Some humans are intelligent, or Sachin likes cricket. To represent the above statements, propositional logic is not sufficient, so we required some more powerful logic, such as first-order logic. First-order logic. First-order logic is another way of knowledge representation in artificial intelligence. It is an extension to propositional logic. First-order logic is sufficiently expressive to represent the natural language statements in a concise way. First-order logic is also known as predicate logic or first-order predicate logic. First-order logic is a powerful language that develops information about the objects in a more easy way and can also express the relationship between those objects. First-order logic. First-order logic, like natural language, does not only assume that the world contains facts like propositional logic, but also assumes the following things in the world: objects, A, B, people, numbers, colors, wars, theories, squares, pits, wumpus. Relations. It can be an airy relation such as red, round, is adjacent, or in any relation such as the sister of, brother of, has color, comes between. Function. Father of, best friend, third inning of, end of. Inference in first-order logic. Inference in first-order logic is used to deduce new facts or sentences from existing sentences. Before understanding the first-order logic inference rule, let's understand some basic terminologies used in first-order logic. Substitution. Substitution is a fundamental operation performed on terms and formulas. It occurs in all inference systems in first-order logic. The substitution is complex in the presence of quantifiers in first-order logic. If we write f/x, so it refers to substitute a constant a in place of variable x. Equality. First-order logic does not only use predicate and terms for making atomic sentences, but also uses another way, which is equality in first-order logic. For this, we can use equality symbols which specify that the two terms refer to the same object. Example, brother John equals Smith. As in the above example, the object referred by the brother John is similar to the object referred by Smith. The equality symbol can also be used with negation to represent that two terms are not the same objects. Example, x equals y, which is equivalent to x not equal to y. First-order logic inference rules for quantifier. As propositional logic, we also have inference rules in first-order logic, so following are some basic inference rules in first-order logic. Universal generalization, universal instantiation, existential instantiation, existential introduction. 1. Universal generalization. Universal generalization is a valid inference rule which states that if premise P, C is true for any arbitrary element C in the universe of discourse, then we can have a conclusion as for all x P, X. It can be represented as inference in first-order logic. This rule can be used if we want to show that every element has a similar property. In this rule, x must not appear as a free variable. Example, let's represent p, c, a byte contains 8 bits, so for all x, all bytes contain 8 bits. It will also be true. Universal instantiation is also called as universal elimination, or i.e. is a valid inference rule. It can be applied multiple times to add new sentences. The new kilobits is logically equivalent to the previous kilobits. As per i.e., we can infer any sentence obtained by substituting a ground term for the variable. The i.e. rules state that we can infer any sentence p, c, by substituting a ground term c, a constant within domain x, from for all x for any object in the universe of discourse. It can be represented as inference in first-order logic. 2. Universal instantiation. Universal instantiation. Let's take a famous example. All kings who are greedy are evil. So let our knowledge base contains this detail as in the form of fol. For all king, x, logical and greedy, x, right arrow evil, x. So from this information, we can infer any of the following statements using universal instantiation. King John, logical and greedy, John, right arrow evil, John. King Richard, logical and greedy, Richard, right arrow evil, Richard. King Father John, logical and greedy, Father John, right arrow evil, Father John. 3. Existential instantiation. Existential instantiation is also called as existential elimination, which is a valid inference rule in first-order logic. It can be applied only once to replace the existential sentence. The new kilobits is not logically equivalent to old kilobits, but it will be satisfiable if old kilobits was satisfiable. This rule states that one can infer p, c from the formula given in the form of there exists x for a new constant symbol c. The restriction with this rule is that c used in the rule must be a new term for which p, c is true. It can be represented as inference in first-order logic. Existential instantiation. Example. From the given sentence, there exists x crown, x, logical and on head, x, John. So we can infer, crown, k, logical and on head, k, John, as long as k does not appear in the knowledge base. The above used k is a constant symbol, which is called Skolem constant. The existential instantiation is a special case of Skolemization process. 4. Existential introduction. An existential introduction is also known as an existential generalization, which is a valid inference rule in first-order logic. This rule states that if there is some element C in the universe of discourse which has a property P, then we can infer that there exists something in the universe which has the property P. It can be represented as inference in first-order logic. Example, let's say that Priyanka got good marks in English. Therefore, someone got good marks in English. Generalized modus ponens rule. For the inference process in first-order logic, we have a single inference rule which is called generalized modus ponens. It is lifted version of modus ponens. Generalized modus ponens can be summarized as P implies Q and P is asserted to be true, therefore Q must be true. According to modus ponens, for atomic sentences pi, q, where there is a substitution theta such that subst theta, pi, equals subst theta, pi, it can be represented as below figure. Example. We will use this rule for kings are evil, so we will find some x such that x is king, and x is greedy, so we can infer that x is evil. The example is shown as following. Why first order? First-order logic permits quantification over variables. Higher-order logics permit quantification over functions and predicates. As shown below. Inference with GMP. Forward chaining. Like search, keep proving new things and adding them to the kilobits until we can prove Q. Backward chaining. Find P1, Pn such that knowing them would prove Q. Recursively try to prove P1, Pn. Inference in full. All rules of inference for propositional logic apply to first-order logic. We just need to reduce full sentences to place sentences by instantiating variables and removing quantifiers. Review: full inference. This method of knowledge representation system is based on propositional logic, which is declarative and possesses semantics, but is context-independent, unambiguous, and builds a more expressive logic on a foundation which borrows representational ideas from natural language while avoiding its drawbacks. The language of first-order logic is built around objects and relations. Thank you.